Hello, my name is Matt McDonald. I am a student at Grantham University. This is a video which will be showing you my final project of ET450. My capstone project, I chose to design a robotic hand. This will serve as a prosthetic for an amputee. I'll show you an example of how it works. Put on the glove, and I have the hand. They are connected by wires, which I will explain in a minute. I'm now powering on the device. This is how it would work. The patient or amputee would put on the glove, and they can control it with their, this example is one right hand controller and the left hand is the prosthetic. Now let me get into the actual components of it. This is just a controller, the hand right here, and as you see, it moves the same way that I'm moving my hand. So that is just, it's one option. I have this building this glove. Let me unplug this again and take the glove off and explain exactly how it works. In theory, the glove would be able to be used and plugged into the prosthetic, and the glove is used as a peripheral of just one way to control the hand. Each finger has a flex resistor that when the fingers move, the resistance changes in this entire flex resistor. I have a voltage divider. There is a resistor inside these tubes, and the signal is taken right from the beginning. I'm running 7.4 volts to the hand. So going back to the wire that ran to this glove, the signals and the voltages running through here are power and a ground. That's 7.4 volts. And the ground, and the 5 other wires are just a signal wire, which it'll be a voltage taken from each voltage divider off of each finger. Now, I used an Arduino One board for this. The signals of that voltage divider all come in as analog signals onto the Arduino board, which converts those signals to digital and sends digital outputs to each individual servo in the hand. Here's the servos. I can control, let me turn this back on and I'll show you how the servos move with the movement. So you can see exactly how the servos move. I'll unplug this again. So, going back to the Arduino board, it sends a signal, a digital signal out, which goes to the servos, And the servos also have a power and a ground running to them directly from the 7.4 battery. And that is a basic explanation of how the hand, as I've set it up today, works. Now, as opposed to building this out of solid state electronics and using the Arduino board, there can be different codes written and very easily downloaded via USB wire from your computer. But a code can be sent back to the Arduino board. For example, if you wanted to open or to close all the fingers at the same time, a button or some type of activator could be added to the hand, and this would really depend on the patient's exact needs. But a trigger button could be added to indicate to the servos to close altogether or open altogether, and then that way the hand, the glove that you wear with the flex resistors, wouldn't have to be used. So the glove I'm thinking of as a peripheral to the prosthetic hand, and there's many different options of programming to make the hand do different movements and activate the movement by a different method with the use of this Arduino board. Some things that I learned during this project was the quality of the parts. In the future, if I were to manufacture these, I would buy better servos. There's 3 servos here that I did have to replace. The ones that I initially bought had plastic gears and they stripped out very easily. And there's also these flex resistors, which I do not think are the best design. They crack right at this point where the soldering legs are. So those are 2 elements of the design that I believe can be improved, but it does work as is. I would still have to say this is a working experiment. And any questions, of course, can be emailed directly to me, mmacdonald1@grantham.edu. And this is the ending of the capstone project. I am happy with this hand, and I will continue working on improvements for the future. Thank you for watching.